Okay, what's the derivative of y to the 5th power? What? Y to the 5th power. So normally we're used to seeing x to the 5th power, right? So this is saying we're taking the derivative of y to the 5th with respect to x. Getting warmer. For the polynomial y to the 5th, we bring the power down, right? 5y to the 4th. This is actually ends up being chain rule. dy dx. Why is it chain rule? Why is y to the 5th a chain rule? Yeah, what's stuffed in? Y is inserted into y is stuffed into y to the 5th. So f of x is y to the 5th, and g of x is just y. The derivative of f would be 5y to the 4th, right? What's the derivative of y? dy dx. Didn't we just do that one? So, first d last, or, sorry, that's the wrong one. We have chain rule. Anyone remember chain rule? Yep. So when we have f of g of x, we get f prime of g of x times g prime of x. So f prime was 5y to the 4th, which we have 5y to the 4th. Is g inserted inside? Yeah, it's right there. G was y. And then we have this times dy dx. Or you can think of it as just do the normal power rule, but if you're taking the derivative of y with respect to x, there has to be a dy dx. Because if you're taking the derivative of x with respect to x, it's dx dx. And dx dx is 1. Let's write that up here. So if you're taking the derivative of x with respect to x, we get dx dx, which is 1. So the new thing for today is that we're taking derivatives of y's with respect to x. So we'll end up getting this ratio, it's not a fraction, this ratio dy dx. Oh, that's the next one. It's right here. I didn't see that. Okay, derivative of x with respect to x is dx dx. But dx dx is, review, 1. So that's why we don't write dx dx. Even though you've had this random dx dx technically in all of your derivative problems so far, we don't write it though because it's 1. Okay, the derivative of 3x with respect to x. What would that derivative be? 3 dx dx, which is just 3. Okay, now this next one I can't see. 4x to the 7th power. What's the derivative of 4x to the 7th power? What, John? Or Jake, sorry. I missed the 8. Let's try writing that again. 28x to the dx dx. So we took the derivative of x, that was the variable, with respect to x. So we get dx dx, which is just 28x to the 6th. Okay? So, number 1. what goes on the top with d dx is what variable you're taking the derivative of. So up here, we are taking the derivative of y, and y's derivative itself is just 1. Yeah. Okay, so number 1, you guys can do this one. This is just a polynomial. If we took the find dy dx, well, the derivative of y is, we just did this, dy dx, which equals, if we find the derivative, John, what would you tell me the derivative of that polynomial would be? And then technically, it's dx dx, because we're taking the derivative of the variable x with respect to x. But we don't write dx dx, because dx dx is just 1. So we're asked to find dy dx. The derivative of y with respect to x is 2x minus 3. Okay? Now number 2, the y is not isolated on one side. It's inside everything. So, piece by piece, the derivative of 5, Rebecca, would be 0. Okay? Now, if we take the derivative, of 2x, Rebecca, what would you say that would be? 2 dx dx, right? Okay, can you see what about 3y? Derivative of 3y. So plus 3 dy dx. So we took the derivative of y with respect to x. Okay, and moving down the line, Claudia, what's the derivative of negative x squared? Good. Any questions so far?
What determines whether it's dx dx or dy dx is
What variable you're taking the derivative of?
It doesn't matter if we're finding dy dx or just d over dx. We'll always use the variable
that you're taking the derivative of. Okay, now we know all the dx dx's are 1, so that's just going to be 2 plus 3 dy dx. We're actually solving for it. It's not anything like 1, so it's still in there, minus 2x. Now, can you solve for dy dx? The directions say find dy dx, the derivative of y with respect to x. So what does finding dy dx mean? Solving with inverse operations. So you want to isolate it, get it by itself. So anything that's, either you need to move dy dx to the left, or you need to move everything else to the left. Yeah? Sure, yeah. Okay, I think we're almost there. Okay, Howard, what did you do first to isolate dy dx? You could have also chosen to subtract 2 and add 2x, right? Okay, so we have negative 3 dy dx equals 2 minus 2x. Then what, Howard? Divide by negative 3, divide by negative 3. So we get dy dx equals 2x minus 2 over 3. Because I'm putting it like x's, and then that's how we write or mx plus b. So we like to see the x's generally first. Negative 2 divided by negative 3 would make it positive 2, right? And then positive 2 divided by negative 3 would be a negative 2. Okay? These two had a good question. Could we have solved for y at the beginning and then taken the derivative secondly? Yeah. Okay? So on number 3, we could solve for y if we want, but y cubed, you'd end up getting like a cubed root in there, so you might want to save that till the end. Okay, so the derivative of 4x. Ariel, what's the derivative of 4x? Dx dx. Good. For a while we're going to practice doing this dx dx, so we know every term we take a derivative of we'll have like a dy dx or a dx dx, and then eventually you can drop the dx dx. Okay, the derivative of the next part, Amisha. Thank you. Okay, Joanna, the derivative of negative 3/5 x to the 5th power. Okay, let's look at, I'm going to rewrite it with just a fraction in the front, then x to the 5th power. Times the fraction, which would end up being what for the fraction? Negative 3. Yeah, because that 5 comes in front and times is to negative 3/5. And then we have to subtract 1, right? Okay, so we would get x to the 4th, and then, there you go. Yeah, when they have the fraction like this, where the x is part of the fraction, I would just rewrite it with the negative 3/5 outside. It helps my brain definitely to see it outside versus a part of the x. Okay, and Jake, the next piece. I have a 3 on the exponent. Do you have a 3? Okay. 20. It's early. Long weekend. Okay. 27 y squared. There you go. Okay. Now solve for dy dx. You could first go through and drop all the dx dx's, right? And then solve for it. When you think you have it, raise your hand. Ooh, someone's cell phone's on the ground back here. I'm just going to put it on the desk behind you. I don't think you need a square root. But we're not solving for y, we're solving for dy dx. Yeah, so clarification. The y squared, yeah, is going to be on the other side. Dy dx is what you're solving for. Good. I don't think it's negative. Let's see what's happened. Oh, okay. Yeah, so I just have mine on the opposite side. So you have a negative and I... Okay, as long as all your signs are opposite, then that would work. Good. Okay, volunteer to go up to the board and show us. Okay, Jake was last. Jake, pick someone. Pick someone to go to the board and solve it. Yeah, here, we'll go up to the line tool. See if you can bring it down. The line tool and make it skinny. Okay. Okay. I'd maybe underline it. Remember, underline it like here. And you need to make it work as easy to follow as possible. Okay, so the reader will know what you're doing, be able to follow your train of thought. To the where there's something else there. There's a +4, yeah. Well, at first I thought it was to the power of 4, but then the 4 just doesn't have a plus sign. Good. So y squared is part of the function on the other side, right? Great, thank you. Now, Gisu had negative 27y squared, right? Which is technically equivalent as long as this 3 was negative, the 14 is positive, and the 4 is negative. So it's technically equivalent, so it's okay. All right. If you would do that review problem, please, by yourself. And then try number 4 as well. Do the review and number 4. We're finding dy dx in all of these, by the way. And number 4. Yep. Good. Now you need to put dy dx equals that. We need a y. That sign needs a y, a y, a y. Okay. Yeah, technically it's equivalent to what I have. Do you know what this reciprocal functions equal to? It's either secant, cosecant, or cotangent. Okay, a number, well, it just doesn't have a number. The review problem, to find the derivative of cosine 2x, what rule do we have to apply to that? Chain rule. So hopefully you're getting more and more comfortable recognizing that this is a function within a function. So f was cosine x, g was 2x, right? So what's the derivative of cosine? Negative sine, and it's not just negative sine x. And the derivative of g is 2. So the derivative of y was dy dx equals, we do f prime of g times g prime, so negative sine of g 2x times g prime. Yeah, you could leave it like that. We usually like to see the multiplication in the front. Negative 2 sine of 2x. Any question on the review one? Okay, now this one, derivative of x is 1 dx dx. Derivative of cosine y. Why is it not just negative sine y? Yeah, because the derivative is of y is dy dx. We need that dy dx. And the derivative of 5 is 0. So we solve for dy dx. Minus 1, minus 1. Negative sine y dy dx. Negative 1. Make sure sine has its variable. It's not negative sine of dy dx. It's negative sine of y. Okay, so divide by sine y, negative sine y. Dy dx equals positive, because a negative divided by negative is positive. So you want to also remember what 1 over sine is? Cosecant. So technically this is equivalent, but you could also say dy dx equals cosecant of y, not x. Okay? How are you feeling on implicit differentiation? You want to try the next 3? They're like, no. Okay, try the next 3. Once you have all 3, or if you get stuck, something, raise your hand. And then we have some fun stuff on the back. Now, careful. There, I foresee some multiplication there. And what do you do when you're taking a derivative of things being times? Product rule. Maybe you should try number 5 and stop, and then we'll check to make sure everyone's doing product rule correctly before we do 6 and 7. Yep, if you ever take the derivative of a y variable, you should have a dy dx come out of it. Yeah, and you have two weird dy dx's. What is it? Times is like a plus sign, right? First d last plus last d first. Since it's add, it doesn't really matter. First d last plus last d first. I think the first part starts with first. First d last plus, and the last part starts with last. Last d first. You have it, Rebecca? Mm-hmm. Yep. Ooh, I don't have a tangent. Let's see. 2xy, okay. Minus secant squared x, that should not have a y. You need to take the derivative of tangent. I don't think you ever took the derivative of tangent. But the product rule applies to this part. Because that's being subtracted. Yeah, that doesn't work. It's just the negative x squared times the y that has the product rule. And this needs to say equals dy dx. Okay, should we go through it? Now, the product rule doesn't have anything to do with the tangent. The product rule is just these two being multiplied. So what's the derivative of tangent x? Secant squared x. Now we'll apply the product rule to negative x squared times y. So product rule, the derivative of f of x times g of x is what again? First d last plus multiplication, flip it over, plus last d first. Okay, so f is negative x squared, that's our first, and g is y. Okay, so first is negative x squared. D last, what's the derivative of the last? 1 dy dx, which I can just put dy dx. Plus last, what was the last piece? Y. D first, the derivative of negative x squared. Negative 2x equals the derivative of 4, which is 0. Any questions on that part? Okay, now just isolating dy dx. I would subtract. Oops, it's not skinny. Still not skinny. Okay, make sure you're working on making your work followable. Is that someone can follow your train of thought? Because that's how you get partial points. Even if you have it wrong, if you've done some of it right, you'll get some partial points. But if we can't follow your work, then you're not going to be getting those partial points. So I underline, I do an upside down T a lot. Whenever I'm doing inverse operations, I do upside down T's. I guess I don't really need those parentheses right there, huh? Then I divide by what? Negative x squared, so there's my upside down T. Divide by, oops, negative x squared. Really nice, it needs to be skinny, but it's not being skinny. Negative x squared. So, dy dx equals, I guess you can leave it like that because it's equivalent, but clean it up a little bit. I could get a positive secant squared x. Now right now this is positive, right? Positive 2xy. So I can subtract 2xy because of the denominator has a negative sign. Make that positive. I would say that is dy dx. If your denominator is negative, though, your signs would be opposite in the numerator. Your secant would be negative, and your 2xy would be positive, right? If you keep the negative sign with the denominator. Okay. Let's just do 1 of 6 and 7 because I'd like to do the back. So let's do, I think number 6 we should do because it has a couple. How many product rules are there in number 6? There are 2 product rules. 5x times y is one of the product rules. Then we have another product rule here, negative 3x squared times y. Okay, so do number 6, and then we'll move on to the back. If you get stuck or finished, please raise your hand. Firsty last plus lasty first. Remember, if you're ever taking a derivative of the y, you have to have a dy dx. What does this say? Okay. I can read it. Yeah, that's fine.
I know my X is
Yes, because pi is a constant, right? You give the negative to all of them. The way you've done it, you've given that negative, you should probably put brackets. You can either choose to give the negative to the 3 as you're taking the derivative, or if you distribute it out, you need to make sure you put brackets and give it to everything inside. So for this one, pi is a constant, so that's just 0. Derivative of a constant is 0. Let's see here. It's 5x is a spot. Let's see. First last plus last first minus What are you doing here? Oh, you're getting your like terms together. Is that what you're doing? Things with x's. Okay. Okay. And here, minus. All of these, this is the error, both of these have dy dx. So when you got your like pieces together, you only gave it to the negative 3x squared. So when you do that, you need to put the quantity, which means you don't subtract it, you divide all of that, so the 5x is in the denominator. Do you have a question, or you're done? Okay. So if they both have it, that means they have it in common. You can factor, right? You can put the quantity times dy dx, negative 3x squared plus 5x. And then you'll be able to finish it. Yep. Yeah, I just have opposite signs, but that's equivalent.
Dy dx. Yeah, let's say that. So you factor out. So what do you do with dy dx?
You can factor out if they both have dy dx's, then that would become 5x minus 3x squared factored out of dy dx.
Okay.
And then you can just divide that piece away. I think that's the easiest move.
Okay, awesome.
Good work, guys. These are kind of thought involved. First do last plus last do first. 5xy, the derivative would be first is 5x. D last, the derivative of y is dy dx. Plus last, d first, the derivative of 5x is 5. I think most of us got this part. Now, the second part is where you can run into an issue. There are two different ways to do this. You can do the negative factored outside and just work with the positives. But if you do that, you have to make sure you give brackets. And everything will have to have the negative distributed back in. Or you can say that the negative belongs to the 3. So, oops, okay, that's not erasing. I chose to give the negative to the 3 so I won't have to remember to distribute it back in. But if you put the negative separately, make sure you do big brackets or parentheses and distribute the negative back in. First would be negative 3x squared. D last is dy dx. Plus last is y. D first is negative 6x. Yep, just negative 6x. Equals the derivative of pi, which is a constant of 0. Okay, so to just clean it up a little bit, I have 5x dy dx plus 5y minus 3x squared dy dx minus 6xy equals 0. So if you had factored out the minus and did parentheses, once you distribute it in, you should now match this line. Any questions about that? Okay, now some of you said, oh, we have an issue. There's two dy dx's, right? I noticed Yisu got her x terms together, which might help. Those are all x terms with the well, I guess it's the dy dx terms together. Okay, so you have your 5x dy dx minus 3x squared dy dx. And these are the non-dy dx terms. Well, if they have something in common, they're like terms, you can factor out 5x minus 3 dy dx. That's the trick. Take everyone around and showed a few people that. Any questions on how I get this? They both have dy dx. What? Oh, yes. X squared. Thank you. Plus 5y minus 6x squared. And then you can go and solve for dy dx. Yeah, we're not done. These are long. Minus 5y plus 6xy equals minus 5y plus 6xy. See how this is, at least in my opinion, nicely organized, so I can see I've done it to both sides. It's not like floating on the top anywhere. And then I nicely cancel out what cancels. Okay, so we have, in parentheses, 5x minus 3x squared dy dx equals negative 5y plus 6xy. And the last step would be to what? Divide by that binomial 5x minus 3x squared on both sides. Okay, cancel. So, I saw this answer for those who'd finished in two different ways. Sometimes their signs varied a little bit. So, the other way, if you had opposite signs, then in my numerator, it should be positive 5y minus 6xy. My denominator should be negative 5x plus 3x squared. But they're both equivalent, right? Just the negative has been put in a different place. Okay, flip it over to the back. X squared plus y equals 25. We're going to find a tangent line at 3, negative 4, and find the tangent line parallel to the x-axis. When you see x squared plus y equals 25, can you show me what type of graph would that look like? Is it a line? Is it a parabola? What type of graph is x squared plus y equals 25? Oh, you're warm. She says ellipse. It's similar. It is a circle. Can I go to the next page now? Okay. This is a circle centered at the origin. Very nice circle. Because if you remember, x minus h squared plus y minus, I think it's k squared, equals your radius squared. In this case, h and k are 0, so that's our origin. The radius in this case is what? 5. So draw yourself a little picture. You have 5, negative 5. That's a really bad circle. Negative 5. We want to find the line that's tangent to the circle. This is why we have to do implicit differentiation. Today is the first time we're taking a derivative of something that's not a function. Why is a circle not a function? The vertical line test. Anywhere in the circle, unless I guess if I'm at the far ends, we'll be hitting 2 points, which means it's not a function. So we use implicit differentiation when we're dealing with non-functions. So 3, negative 4 is approximately right there. And we want to find, part A, the tangent line. Would you turn to your neighbor and tell them, when you see tangent line, find the tangent line, what should you do? Turn to your neighbor and tell them, when you see tangent line, what should you think to do? Okay, Ariel, what'd you get? What do we do when we see tangent line? Find the derivative. Okay? So for part A, the derivative. Reed, would you go through and tell me what the derivative would be? Great. So this becomes 2x plus 2y dy dx equals 0. Now that's just for any tangent anywhere on the circle. And we want it specifically at 3, -4. So what do we do if we want to find the tangent line at a specific point? 3, -4. What do we do then? Plug in 3, just 3, and -4. So now we're going to do 2 times 3 plus 2 times -4 dy dx equals 0. When we plug in the actual point, what's it going to tell us? The slope of the tangent line, and the tangent line's name is, what do we call the derivative? dy dx. So we have to solve for dy dx and log the slope of that. So we have 6, not plus, minus 8 dy dx equals 0. Add 6, nice upside down t, cancels out. -8 dy dx, huh? Oh, yep, thank you. Divide by -8. So the slope of the tangent line at point 3, -4 is 6/8 or 3/4. Okay, but it wants, for part A, it wants the tangent line. We now know the slope of that line, but if it says tangent line, we can take the derivative, and our answer has to be an equation, not just a slope. Point slope form, our friend. Y, I know lots of you already put the minus, that would be plus y1 over there, right?
So there's y dx plus the x and the y at the top and the x at the bottom, or just the y at the top? So I'm still on A.
This is the slope. We are also on A. This is n.
I'm not talking there. I'm talking the x. Yeah, so we plug 3 in for D.
That's not D. It's x.
Oh.
X, comma, y.
Oh.
And y is -4. Okay. And this dy dx is our variable m, the slope. And our y1 and x1 are these guys, right? x1, y1. So we have y equals our slope, 3/4, times x minus, what do I write? 3 plus -4. And you can stop there. You don't have to go any further unless it says some other form, like standard form or slope-intercept form. You can stop. That's part A. Part B, find the tangent line parallel to the x-axis. Can you show me what that line would look like if it's parallel to the x-axis? Where's it going to be? Ah, it's going to be flat. Where on the circle do we get a flat slope, or a slope of, what's the slope of a flat line? 0. Where on the circle do we get a slope of 0? Here and here? That's x equals -5 and 5. Ah, y equals. So there are actually 2 places, right? There and here. So we want our tangent line to be parallel to the y-axis at here and here. Well, we know our slope parallel to the x-axis. We know the slope is 0, right? So y equals 0 times x minus, which one do you want to do first? The positive one? Let's do the positive one. Minus, this is the point 0, 5, so the x would be 0. Plus 5, we have y equals x plus 5. And does that actually make sense because the y-intercept is 5? Oh, because we times by 0. Haha. Yes. And the slope is 0, and it crosses the y-axis at the intercept y equals 5. That's one of them, but there are two. So you can probably just even tell me. Yeah. -5. Okay, the bell is going to ring shortly, but let's at least practice taking the derivative of number 9.
So, say we didn't, say this one wasn't so easy, how would we find so nice.
Well, if you're finding something parallel to the x-axis, you know the slope is 0. It's the point, whatever. You'd plug in whatever slope you had. If it's parallel to the x-axis, the slope is 0. And you plug in whichever point you're looking at.
So the thing is, what if it wasn't, what if we didn't know? So like right now it's easy, it's at 0 and 5. But what if we didn't know it was at 0 and 5? What do we have to, how do we solve?
Well, then it's a quadratic, because the top of the circle is a quadratic. The bottom of the circle is also a quadratic, so it's the vertex of the quadratic. I don't think we have those right now. But if we see one on the homework, we'll talk about it next time. Okay. Really quick, what's the derivative of our function on number 9? 2x squared, or x squared would just become 2x. Now, first last, I'm going to take the negative with the x. First, last, derivative of y is dy dx. Oh, that's it. That's all, folks. Okay? You still have your homework sheet, right? That has, I think it has the rest of chapter 4. So it has 4.2 and 4.4, so you're good for a couple more days. Next time I'll give you a what's-see, and you'll have a week to work on it. You're going to bring questions on 4.2. This is 4.2. So you bring questions on 4.2 next time. Make sure you have those dy dx's anytime you take a derivative of a y with respect to x.